Hello everyone, welcome to our webinar and thank you for finding time and joining today's webinar. My name is Megan and I'm from GoodWe Solar Academy. Today I will be the host of the webinar and the topic of today's webinar is Optimize Your Energy Storage System. This webinar is jointly held by BYD and GoodWe. GoodWe is a leading enterprise that focuses on research and manufacture of solar inverters. With 7 years experience of energy storage product development and application, in 2019, GoodWe ranked as the global #1 energy storage inverter supplier by Wood Mackenzie. And our partnership with BYD started in 2016. The BYD Battery-Box meets the highest standards and also wins many awards. Both of the two companies are dedicated of providing high-quality energy storage products and solutions. So I believe all of you can have a better understanding of our energy storage system after the webinar. Okay, now let me introduce the agenda and speakers of today's webinar. We will be joined by Jack Stone, the Supervisor of GoodWe Solar Academy, and Jay Chua, the Senior Service Engineer of BYD. And both of them will give us an introduction for about 30 minutes. And Jack will give us an overview of GoodWe's three-phase energy storage system overviews, and then introduce the unbalanced output function for us. And Jay will give us the introduction of BYD Battery-Box Premium. At the end of each introduction, we will have a Q&A session. So you can type your question, And you can type your question at the chat board or through the Q&A button when you have the question. So we will collect them and our engineer will answer them at the Q&A part. And after the introduction, we will see the video about ET installation and configuration with BYD HVS battery. After that, we'll go to the exciting quiz and giveaway part. So that's all for our agenda. Now let's welcome Jack to give us the introduction.
Okay, thanks again for introduction. This is Jacob from Solar Academy. Today I will have an introduction about our three-phase hybrid inverters with unbalanced output function. Okay, and okay, this is it. So this is the topic we talk today about our hybrid inverter, GoodWe hybrid inverter. And after my introduction, our partner BYD will introduce their batteries. Okay, before my introduction, I will have a brief talking about the relationship between BYD and GoodWe. BYD and GoodWe have a long-term cooperation in the market, from a few years ago, and we have established the cooperation and have a lot of projects outside in the market. And also we have do the compatibility between GoodWe hybrid inverter and the BYD batteries. Like HVM and HVS, the new battery from BYD will all have the compatibilities, and here we have show up them the paper document we signed for the compatibility between BYD and GoodWe. Okay, and it's not just HVM and HVS, also HVO, LVS, low voltage, high voltage with GoodWe hybrid inverters, all compatible for now. Okay. And also here I have a brief introduction about the general picture of GoodWe hybrid inverters. Okay, for our energy storage inverter, we have two different types. We have coupled, also we have hybrids. Okay, for hybrids we have single phase and three phase with low voltage and high voltage. And for example, like this one, ES and EH, it is the single phase hybrid inverter from 3 to max 6 kilowatts for single phase. Okay. Also behind me, you can see the rear motors. And ET and BT, this is three-phase energy storage. ET is the hybrid three-phase with the high voltage battery from 5 to 10 kilowatts, and BT is a three-phase AC coupled. Okay, and another type is what we talk like BT is AC coupled. AC coupled means it's used with ongoing inverters with our AC coupled inverters. Okay, because it's not used independently because it's kind of AC charger something. Okay, it can charge the battery from AC side and coupled with on-grid inverters, on-grid systems on the AC side. Okay, for AC coupled inverters, we also have single phase and three phase with low voltage and high voltage. This option. For single phase, we have SPP is used with low voltage. Low voltage we mean 48 volts, and BH is also single phase, but it uses high voltage battery. High voltage battery is from 85 volts to 495 volts. And for BT, the three phase is all use high voltage batteries. Okay, three phase is from 5 to 10 kilowatts like ET. The capacity is the same. Okay, but it's coupled. It does not connect PV directly. Okay. And this is a general picture, general features of our hybrid inverters, and also it's a coupled inverters. It's the first one is without fans. It's designed without fans because our hybrid inverter and AC coupled inverters normally it's used inside the house. It's a residential type. So without fans, it means lower noise. Okay, so it's very suitable for house use. Okay. Another is IP65. IP65, you know, except for installed inside the house, sometimes the inverter is installed outside with battery. Also, sometimes it's installed in the garage or somewhere, you know. It's not protected so well. So IP65 protection is for such use outside or used in, you know, somewhere is not so protected from the outside the ambient temperature, ambient environment. And another feature is integrated functions. Integrated functions, it means, you know, all the functions like MPP tracker, like DC-DC charger, like backup function, also the grid connection function. It's all integrated inside in the same unit. It's not separated units, okay? As we know, in the European countries, in the European brands, and also American brands, you know, their local brands, normally they intend to use AC coupled. AC coupled means the inverter, the energy storage inverter, the PV inverter, and maybe the DC charger, and also the backup units. It's all separated units. So for the installations, for the cooperation of all the functions, it's not so good as the integrated ones. Okay. So so for GoodWe energy storage inverters, or integrated with all the functions it's needed for the house use in the energy storage scenarios. Another feature is the full range of power ability. This full range power means it's used for residential. Okay, for residential, normally the power is up to 10 kilowatts. Okay, sometimes it's higher than 10 kilowatts, but it's not normal use. Okay, normally it's from maybe 1 kilowatt to 10 kilowatts. And our hybrid inverter is used for residential, so it's up to 10 kilowatts for single units. And the lowest power for the inverter is 3 kilowatts. Okay, so the power range is from 3 to 10 kilowatts. Okay, it's perfect for residential use. Of course, it has a lower power, like it's lower than 3 kilowatts, but it's not normally used in the house. In the house, normally it's higher than 3 kilowatts. Okay, so this is a general picture, general features of our hybrid inverter. And from here, we will talk about the main topic we will concern today. It's about unbalanced output function. Unbalanced output function, it's used in 3 phases because it's unbalanced, right? So single phase isn't, there's no function for like unbalance in a single phase. So for 3 phase, unbalanced output function, it's very important for now, okay? Because in some place, here also listed the scenarios we will use, okay? So first is phase level 0 export function. Okay, first level 0 exports. Later I will have a detailed introduction about this scenario. And another scenario is a self-use smart energy management. Actually, for now, all the energy storage inverters they can use for self-use. This is a basic function about energy storage inverters. Okay, but how high self-use ratio is? This is maybe the main concern for you know, a lot of our markets, especially with the low feed-in tariff and high electricity price. Okay, later I will have detailed introduce. This is the function, how we realize the function, and maybe we can say how we realize unbalanced output, how we increase the benefits for the users from the unbalanced output function. Okay, with unbalanced output function, actually we realize the function of power sharing between phases inside the inverter. It's not dependent on the external device. Okay, it's all realized inside the inverter. Okay, there's no external device, like I said in the first picture. All the inverters is integrated functions, integrated with all the functions. So it's not used with other functions. So and these functions is also realized inside the inverter itself. Okay, and here is the first scenario. Before we talk about the benefits of unbalanced outputs, and this picture, we give a general introduction about the traditional outputs of 3 phase. We call it balanced outputs. Okay, balanced output, it means that the output sides of the inverter, okay, each phase they have to output the same power. Like here, we have a 10 kilowatt inverter, but from PV we have 7 kilowatts, 1 kilowatt is charged battery. So the inverter will output on the AC side 6 kilowatts. Okay, 6 kilowatts, it means on each phase you have to output 2 kilowatts balanced. So this is what we call the balanced output. This is a traditional function about 3 phase solar inverters. Okay, no matter it's on-grid inverter or hybrid inverter, it's the same. Okay, this is a traditional. All the phases it's balanced outputs. Okay, so if it's balanced output, so we can say here if the power consumption on each phase in the house is different. Okay, so it means on maybe on one of the phases they have to export to grid, and another phase they have to buy power from the grid. Okay, they exchange from the grids, so it's not consumed by himself. Okay, so this is a traditional balanced output system introduction, and compared with the balanced outputs, GoodWe 3-phase hybrids and AC coupled inverters, they support unbalanced outputs. The unbalanced outputs. Unbalanced outputs, it means on the AC side, output sides, okay, on each phase, they can output different power, okay. Like here, ET series, we take 10 kilowatts as an example. From the PV, we have 6 kilowatts. And from the inverter charged battery, 1 kilowatt charged battery, and have another 5 kilowatts export output from the inverter on the AC side. But the output power could be different on each phases. It depends on how much power is connected on each phase. Okay. In this scenario, we can see that on the first phase, the power consumption is 1.5 kilowatts. So accordingly, on the first phase, the output from the ET inverters is 1.5 kilowatts. And another phase, the third phase is 2.5 kilowatts, and the output is the same. Okay, so the outputs could be at some level. It depends on the power consumption on each phase. Okay, but of course it has limitation. It's not just you know, it's not to have Not like that if we have no limitation, it can output as much as possible. Of course not. First limitation is should be dependent on the general power. Okay, general power, rated power of the inverter. For this one, it is 10 kilowatts. So all the outputs, the general outputs on all three phases, it cannot exceed 10 kilowatts. This is the first limitation. Another limitation is about each phase. Okay, about each phase, the output power is limited from 0 kilowatts to 33% of the nominal power of the inverter. Okay, like 10 kilowatts on each phase, they can output range from 0 kilowatts to 3.3 kilowatts. Okay, so this is the two limitations, and this is also important for the use of a three-phase hybrid inverters. Okay, and all the hybrid motors, three-phase and single-phase, okay, they can work in a lot of scenarios for self-use, for export power limit, okay. But for three-phase, it's used in the three-phase house grid system, and especially for zero exports with phase level zero exports that I've introduced. And this one is also a scenario about zero exports, phase level zero exports. Phase level zero exports, it means on each phase, the export power limit has to be 0, okay? It's not a general requirement around the world actually, but as I say, more and more countries and users require for these functions, especially in European, like in Czech Republic and Spain, they also have such a requirement. They have a very clear requirement about this function, okay? Like because in Spain, it's required the zero export. It means each phase you cannot export, okay? Like in the first picture, I have introduced the balanced outputs. In the balanced output systems, if it is used in Spain, it cannot be used because the outputs of the inverter, they have to exchange from grids. Like I said, one phase, they buy power from the grid, and another phase, they export to the grid. Okay, this is not allowed in Spain, and also, of course, in other places, a lot of other places like Czech Republic, also in some places in Germany, and also in Spain. And in the future, like I said, maybe if you change it in Italy and other European countries, North European countries. Okay. Here we can see with the unbalanced output function. For example, the second phase, we did not connect any loads. There's no power consumption. Okay, but on the first and third phase, we have load power. So if with unbalanced functions, the second phase, we do not have to export power. And the power on the second phase will be shared to the first and the third phase inside the inverter, okay? Just before the meter, before the power meter of the house, in the house, okay? So again, say here, the first phase and second the third phase, its output power is dependent on the loads on each phase, and the second power is limited. Second power is limited, okay? It's limited to 0. So this is for phase level zero export control. This is very important. Without unbalanced functions, it cannot realize this function, okay? Okay, except for unbalanced output, we also have another function for, especially for three-phase coupling motors. It's unbalanced charge. Unbalanced charge, you know, like what it calls. Unbalanced charge, it means that the power from the AC side can charge the battery, okay? But here's three-phase. The three-phase can have different power injection to the inverter, and okay. Like here, it's a coupled. This is a coupled. Okay, it's three-phase. It's a coupled BT series inverters. It is used with a three-phase on-grid inverter here, and from the solar power, have a 9 kilowatts from solar, and the power of the loads is not so high, so that they cannot use all the power from the solar. The rest of the solar will be used to charge the battery. You know, its priority is load first and then battery, right? Like here, the load power, the total load power is 4 kilowatts, and the power from solar is 9 kilowatts. So they have another 5 kilowatts to charge the battery. Okay, so on the first phase and second phase, they have a power consumption from the loads, and the second phase, there's no load consumption. Okay, so on the first phase, after consumption 1.5 kilowatts, they have still have 1.5 kilowatts rest exit power to charge the battery. And the second phase, they have 3 kilowatts. And on third phase, they have only 0.5 kilowatts to charge the battery, right? So if without unbalanced output, unbalanced charge function, okay, the power of 5 kilowatts, they cannot charge the battery. All the power cannot charge the battery, okay? They will charge the battery or 0.5 kilowatts on each phase, okay? But with unbalanced charge function, on each phase, they can have different power from AC side, from the solar, from on-grid inverters, on-grid systems to charge the battery, okay? So this unbalanced output and unbalanced charge function, it's very, very useful in the scenarios to increase the self-use of solar power, and also to increase the production of the solar power, especially in some place in these scenarios with zero export function, zero export power limit function. Okay, so till now we have introduced about the unbalanced charge and also unbalanced outputs, and all the functions is realized in our 3-phase energy storage inverters. On-grid inverters that cannot realize this. Okay, only storage inverters. It's coupled or hybrids. Only energy storage 3-phase. Okay. From here we can see clearly how the unbalanced output and the unbalanced charge function can help to increase the self-use, increase the solar production. Okay. This is the comparing between the systems with unbalanced output and without unbalanced outputs. Okay, of course with a zero export function. We talked this first. Unbalanced outputs. Unbalanced outputs, like I said, because you know, especially in the scenarios with a zero export power limit function, power limit or requirement. On each phase, they cannot export to the grid, right? So the production from the solar, from the inverter, they have to, you know, after the consumption of the loads on each phase, they have to follow the lowest power of all the phases. Okay, of course, like all 3 phases, the max outputs on phase 1 to the grid or to charge the battery is 2 kilowatts. The lowest power on phase 3, for example, on phase 3, it's 0.5 kilowatts to charge the battery or to support the loads, right? But without unbalanced function, all the production on all 3 phases, they have to follow 0.5 kilowatts. So on phase 1 and phase 2, they have to limit the production of the solar systems. Okay, so generally we can see the diagram of the production of the solar with unbalanced output function. The production from the solar can be you know, as high as possible. It can maximize the solar production, and without unbalanced function, the solar production will be limited like this. Because it depends on the load, loads of each phase. Okay, so here the first benefit is increase the solar production. Of course, also just decrease the power from the grid, from the grid, right? And another benefit you can see here is to increase the self-use of the solar power. Because in the same scenarios with the three-phase power meter in the house, and the the calculation of the power by from grids. In some meters, they calculate the power on each phase. Okay, balanced on each phase. For example, the first phase they have by power from the grids 1 kilowatts and another 3 kilowatts. Then the total is 4 kilowatts. It did not calculate the power export to grids. Okay, if they do not calculate the power export to grids, if the power meter works like that, with unbalanced outputs, they can increase the self-use of peak power because they do not export to grids. Okay, they just share with another phases, between all the three phases to power the loads on all the three phases. Okay, they do not have to exchange it to grid. They just consumed before the power meter of the house. Okay, like here, this is not what we make up. This is a real comparison from the unbalanced output and balanced outputs. Okay, the self-use is very significantly increased. Okay, in the house use systems. Okay. Okay, this is the topic about the unbalanced outputs, and also we have a brief introduction about our company. So here we have we will have a few minutes to introduce our company. GoodWe company is set up from 2010. It's 10 years ago. And also from the 2014, our first hybrid motors into the market and used in Australia. And from 2016, we have built the cooperation with BYD, the partnership cooperation with BYD, and we use with our hybrid motors we use with BYD batteries around the world. Okay. First, it's from their B-Box, okay, low voltage, and for now it's their latest battery version, the HVM and HVS, okay. And from the 2018, we have been the #1 in the market sharing in China. About mostly about the residential parts, okay. And just a few days ago, we just established the stock market code in the market. We are also publicly listed company. We have become the listed company in the market, and listed in China. It means we can collect more money. Okay, so it's very famous for GoodWe both in China and around the world for now. Both on the hybrid inverter and on-grid inverters, residential and commercial. Okay. And also for now, we have built a lot of branches around the world, like in Australia, in Germany, and also in India, in Brazil. We all have our office there. It's a branch company of GoodWe. And we have sales there, we have technical support there, and we now focus on the local language support around the world. Okay, for now we can support more than 10 local language around the world for the service, for the sales and technical support. Okay. Okay, like here, our headquarters is in Suzhou, in China. And we have 3 R&D centers. One is in Shenzhen, is very near to Hong Kong. And another R&D center is, of course, in HQ Suzhou. And also we have built a new R&D center in Australia, in Melbourne. Okay. And also around the world, we can see here, we have branches, like I said, in Brazil, in Australia, and in Germany, and also we also have in North America, in Mexico, in US. We also have a local office. Okay. And here is the how to say, it's awarding of GoodWe to the GoodWe. And from in 2018, we have listed number 4 in the three-phase inverters in the market. Okay, number four is sharing, market sharing. It's listed in the IHS market. It's not made up by GoodWe. And from 2017 to this year, we have continuously won the top brands, the top brand for the consecutive years for Australia and New Zealand for the all quality awards. Okay, continually for 4 years in different 4 different type of inverters. And here is the All Quality Matters Awards. It's from 2015 to 2019. Also continuously for 5 years, we have get the awards for different type of inverters, different for on-grid and hybrid inverters, and also for commercial and the residential inverters. And last year for hybrid inverters, we are listed. We are ranked number 1 for the storage inverters supplier in the last year. This is the Wood magazine list for the, of course, it's for residential and storage. Okay, for residential, for any storage inverters, it's not for battery. It's not including battery. Okay, and in the future we will have our own brand battery, but not now. And this one, red dot, is for our design of the single-phase on-grid inverters. We call it DSS. And red dots, as we know, it's called Industrial Oscar for the design of the inverters. Okay, for the outlook, for the UI design, and of course for the installation of all the general design of the inverters. It's okay, so thanks for listening. This is the introduction today.
And we still have some questions for you. So you can see as the Q&A.
Okay.
Q&A function.
Explain what features are. Okay, here we get some questions from the listeners, from the visitors. The first is that want me explain again what is the features are with AC coupled inverters. Actually, the features, the general features, it's not just for AC coupled inverters, also for all the energy storage inverters. It's a without fans, it's a low noise, and it's a IP65 protection. It can be used outdoors. And also without a display, all configuration is on the app. So without the fragile parts on the inverter, without fans, without displays. And also for three-phase AC coupled inverters, we can support unbalanced charge function. Okay, just remember this word, unbalanced charge function. This is very important. As I know, this is we are the first supplier for AC coupled inverters that can support AC unbalanced charge from the AC side. Okay. Of course, we have another features like the UPS level switch time from the on-grid mode to off-grid mode. Okay, from on-grid condition to the off-grid condition, the switch to the backup supply is 10 milliseconds. So this is also a very important function features about all the general inverters. It's not just AC coupled inverters. And for AC coupled inverters, it can use with all the types of on-grid inverters. Okay, so this is a kind of feature. Okay, and another question is that three-phase unbalanced outputs, or 2 three-phase outputs, or 3 single-phase units. No. For three-phase unbalanced outputs, actually, it's like I said, it's integrated unit. Okay, it's integrated unit. It's not a three-phase. It's not 3 pieces of single-phase together. Okay, it's a general three-phase. Okay, it's just a real three-phase, and the outputs is also real unbalanced outputs. Okay, you asked this question, I think maybe because of solar edge, because solar edge, they can put the 3 single-phase inverters together to build up a 3-phase, right? But we do not do like that way, okay? The inverters from the initial design is a 3-phase, okay? And another question, the third question, it said, what happens if the power requirement of the house is only 4 kilowatts? The battery needs 1 kilowatt and the power from the sun is 10 kilowatts. Okay, actually this one, if the power from the solar is 10 kilowatts and the load house is, the load of the house is 4 kilowatts, and the battery charge 1 kilowatts, and another 5 kilowatts could be exported to grid. If in this scenario, you can export to grid. You're allowed to export to grid. You can export this power to grid. And if it's not allowed to export to grid, then you can configure the system to limit the power from the solar to 5 kilowatts, okay? So this will call export power limit. And what is PV shading? PV shading, like in these slides, like in one of the slides, I have introduced because without unbalanced outputs, okay, and also they need zero export function of the system. On all the 3 phases, phase 1 is 1 kilowatts, phase 2 is 2 kilowatts, phase 3 is 3 kilowatts about the load power, and from the PV, it's 10 kilowatts, just an example, okay? So if without unbalanced output, the output of the inverters on each phase will be 1 kilowatts, because the lowest power consumption on all 3 phases is 1 kilowatts, okay? So if it's only 1 kilowatts, so the total output of the inverter will be 3 kilowatts, okay? But the output ability of the solar system is 10 kilowatts. So this is called shading, PV shading. PV shading is 10 kilowatts shading, okay? If with unbalanced outputs, it means on phase 1 and phase 2, phase 3, they can output the power depend on the load consumption. The total power of the load is 6 kilowatts on all 3 phases, and the outputs from the inverter is also 6 kilowatts. And the rest power could be charged with battery or something, you know, could charge battery. So with unbalanced outputs, the PV shading will be very lower, will be very limited, you know. There's not so much PV shading. This is what we mean PV shading, okay. Okay, and I've tried that. They have another question instead of which inverter won the best design awards. We have different inverters like ET, like a 3-phase ET. We have also EM and DNS, on-grid inverters DNS, and also another one is MT, 3-phase. Okay, 3-phase on-grid inverters all have this word, because each year we have different inverters won this word, one of the best design word. And maybe if you mean the red dots, it's DSS series. You can check our website to find that. Okay. What is the switch over time length grid when grid is off? The switch time, like I said, over time when grid is off is 10 milliseconds. It's a UPS level switch time, 10 milliseconds. Okay. Is the only battery that works is BYD? No, not like this. BYD is the biggest corporation. The biggest partner of GoodWe with battery and GoodWe hybrid inverters. But we're also compatible with other batteries like Danish, Palantec, LG, all compatible. Okay, you can find the compatible list from our website. You can download the paper to check the compatible batteries with our energy storage inverters. Okay. Think what is okay, so if you guys do not have other questions, we will give the talking to our partner BYD. And for the other questions on the list, they cannot, you know, it's not so simple answering. So later I will have, you know, we will answer the questions in another way by email or something. Okay.
Okay. Thank you so much. Now, I think most of you have a better understanding about our unbalanced output function. Now, let's welcome Jay to give us the introduction of BYD Battery-Box Premium.
Hello, is that working? Can you hear me? Yeah, hi. Okay, yeah, William said yes. Okay, my name is Jay. I'm the Senior Service Engineer that works for the BYD Australia division. And normally I'm doing the training for the Australian market, but today, well, thanks GoodWe for the opportunities. We can show the BYD products to the global market here. And I'll just bring up the presentation here. Okay. Yep. All right. And also, I just want to mention that the presentation from Jack is very informative and quite impressive. The GoodWe have that three-phase unbalanced feature that wasn't really released on the on the other inverters before. And okay, I'll start my presentation now. Okay, BYD is it's not a well-known name to the Western world, and just because BYD normally is doing the business behalf of the the electronics or basically doing the batteries, but now all those products, like just thanks for the electric cars, and now BYD as a battery company, which is founded in 1995, getting more attentions and getting more popular in the recent 10 years. And you can see basically the employees of the BYD is not a small company, is having over 200,000 of employees. And it basically, if you doesn't really know what size of that company is, you can think like a Toyota, Apple, like BYD is that size of the company. And we have global offices everywhere in China, Australia, Europe, South Africa, South America, and the USA. And the BYD have 4 major businesses, and in car, the rail transit, and electronics, but today we'll mainly focus on the battery side. So today we're gonna introduce the new BYD premium batteries. I'm not sure if you guys purchased the BYD battery before, but this year we're releasing a new series called the Premium Series. And the first one is the high voltage battery, and basically quite easy to understand. The HVS is high voltage small, and HVM is medium. And this is the 48 volts battery range is low voltage small, and we have a larger battery, it's called the low voltage large, and they're all compatible with different GoodWe inverters. So as I mentioned, the BYD founded in 1995 as a battery manufacturer and have a 25 years in battery R&D and have whole industrial chain for the electric car batteries and also the storage, residential or commercial storage batteries. And everything is, mostly they are like automated, sorry. And we have more than 10 years, that's the batteries that's in our, the BYD electric cars or in other brands, we're sharing the same technology and we have sharing the same experience in the residential applications. Okay, this is just showing, so for most of the batteries you guys maybe purchased before, and those battery manufacturer only have capability doing the module manufacture or the pack manufacture, which is, other parts they are sourcing from other companies. And for few companies, they're able to do a little bit more. They're designing their BMS and they are basically manufacturing the small part of the batteries. But what BYD do is BYD as a company have a control and has the resources to control the whole process from the chemicals to the battery cell, the small, you see those cylindrical or the battery pouch, and design the software, the hardware, and also go to the recycling. But in some of the countries, as I believe they're doing offshore recycling, or in Australia particularly, we have a partner to do recycle locally. And this picture just show you the roadmap of how the battery, the BYD battery box developed. And back in 2015, we released the first gen BYD batteries. You see the battery is just like the a black box with battery modules, those rack versions of the battery. But later we discover, okay, the batteries, you need to look nice. You need to show your friend the battery is very expensive investment, and you need to show this is something, like cars. You need to show your friend. And we then have a patent design. It's a stackable design. And we're the first one to releasing that in the market. And basically after 2 or 3 years, now we're at the third generation is we are making like a further improvements on this stackable design, like to having a larger battery, a larger power output, and a better performance. Okay, this is more on the market share of the BYD batteries, and the source is from online. This only mentioned in Germany market and also European market. So this is the data from 2017, and showing the BYD is only 3% or 4% market share in the Germany market, and that's I believe that's the second year they enter the market, and later next year, from 4% to 13% in 1 year, and BYD become the third in Germany market, which is I would say the Germany market is the most more like on the new technologies, they having more experience, and they more showing the world what's the actually good products or which the best products. And back in 2019, and BYD become second in both market, the European market and also the Germany market. You see the roadmap is from 3 or 4 years ago, we as a company is nowhere to see and nobody knows that. And then later and later each year, we increase dramatically, and basically most of the well-known brand, they already passed by the BYD based on the market share. And we believe we are targeting the #1 in the most market this year. Okay, showing the new products. So first, I'm gonna talk about the 48-volt range. And it's actually in our data sheet, we're using a nominal voltage 51.2 volts. The starting point is 4.0, a LVS low voltage small, and the larger one is a 15.4. So give you a choice is, if customer need a smaller version, the starting point is 4.0. And if they didn't need a larger battery, then they can go with a cheaper and a larger one. And then you can add in more to the system, which is potentially giving you a more than 200 kilowatt hour with the LVS and roughly 1 megawatt hour with the LVL, which is cover most of the cases. And another one is the high voltage battery. Most customers will, normally ask me, why this high voltage, why this 48 volts, why we can't have one version of the battery? So the 48 volts is generally the old traditional that's used for a telecom, and they are more stable. They have many years of the products have a development history. But now the high voltage batteries is entered the market just because it has a battery efficiencies, and they share the same voltage on with the panels. They on the 400 volts voltage range. And this is simply, there's no more DC to DC conversions, and it has a battery efficiency. The starting point is very simple, 5.1 or 8.3, similar story. If customer need a smaller system, they just go with a smaller one. If they need a larger system, and they use the HVM. And also I put in the IP55 and IP20 on the right-hand side is show you basically if you need to install your system outside the house, you go with IP55. If it's indoor, both IP55 and IP20, they both works. And last but not least is for this year, all the BYD Premium series, we all supporting either, doesn't matter is an on-grid, off-grid, single phase, three phase, all supported. The only difference is you need to make sure that the inverters, which is connecting to this battery, they first are compatible. Second is the inverter support off-grid. So on the battery side, on the DC, because we have enough power output, there's no difference to the battery. And furthermore, I would like to cover the features of the battery. So first, when BYD developed the batteries, some people may know we are using what we call lithium iron phosphate. This is a different chemistry. This chemistry is good for on the performance, good for the in this one is the thermal runaway temperatures. Comparing for other chemistries, which is popular in some of other manufacturers, they are doing NCM. You can see basically there's a big difference, and I wouldn't cover too much on it, but I just mentioned when we developed the battery, BYD have both technologies, both applications. The reason why we're selecting this one is we can make the battery cheaper, and the second, we can make the battery safer. And this just show you we have a data till Q4 2019, we have over 48 thousands of installations, and each installation roughly 10 kilowatt hour, and we have 27 countries. This is just show you the awards which is we have in the past few years for the BYD system, and basically I believe GoodWe already mentioned some of them what they mean, and I wouldn't cover too much on it. This is one of the performance, performance rewards, sorry, that done by the third party, and they rank the BYD batteries, especially on the high voltage. As I mentioned, the efficiency is better than the 48 volts. And you can see in most of the, sorry, I have to cover the inverters. So that's the BYD battery with different inverters on the ranking. And you can search this online, and believe me, GoodWe is one of them. And you can see compared to the other battery and the inverter compositions, BYD definitely have a widely compatibility with different inverters, and they are having good efficiency. Some of the certifications I need to show you, but I wouldn't cover that one by one. It's, I know you guys are quite tired now, and I'll try to finish soon, and I will show you basically some of the products that's behind me, just show you the real one. And the patent modular design, as I mentioned, we're the companies, the first one that's having that quick installation and the stack and play. Basically, that's something we want to point out. We are having the design that's leading the market, and you will see the design of that system. You can see from other manufacturers, they are released after us, but we're the first one to having that design. And secondly, high scalabilities. This gives you the option, you purchase one battery, or you having jobs that's a residential, commercial, you want one battery that's cover all the ranges, BYD have that option. And furthermore, this year, we believe we should bring a little bit smart to the batteries, like to let the customer, to let the installer see what's going on, and basically, give the battery a little bit thinking. And we have a new app, which is called the B Connect. And this is, you can commission the batteries, you can doing the updates, you can checking some data locally, and we are putting more features on the app in the second half of this year. Just waiting for the basically the updates on this app. We'll put plenty of the new things on this app after. And secondly, we have a remote service or remote troubleshooting. Is when you're having issues on the old batteries, old BYD batteries, you don't have this ability. Like you cannot connecting the battery to the internet. But now, if you have an internet capability, like if the customer have like a router, you can simply just connecting the router to the batteries through a LAN cable, and we can see the system remotely and help you on the troubleshooting. Just mention that at the moment, the new BYD batteries is only support LAN connection on the internet. The Wi-Fi, which is our built-in Wi-Fi, is only for commissioning at this stage. So, okay, this is the LVS, the low voltage small, and you can have starting point 4.0, and you're putting more and more, and you got one tower, 24 kilowatt hour, and you can parallel 64 of them, then you got 256 kilowatt hours, and this is on the 48 volts range. But today, the main batteries we want to talk about is the HVS and the HVM, which is compatible with the GoodWe ET, BT, and also the EH and the BH, which is their high voltage range. Okay, so why there's two different ones, like the 5.1, the 8.3, like why are you releasing two similar versions? One of the reasons is we call the first one, the HVS, is good for power, and the second one is good for energy. So why is that? Like how you can tell which one good for power, which is good for energy? Simply, we'll do this example is the customer want to do a three-phase ET 10 kilowatt. They want to discharge their batteries, the 10 kilowatt hour batteries in 1 hour, in 60 minutes at 10 kilowatt, which is that's gonna discharge the battery in 1 hour. This require the HVS, which is the performance or the power unit. If the customer, for example, okay, I don't need the battery that powerful, just I can run my 11 kilowatt hour batteries discharge in 2 hours, which is already good enough for most of the load consumptions or appliances, then okay, just go with a cheaper, which is a larger size unit, but a little bit cheaper than the performance one. And this give you two options is, okay, do I need my battery that powerful? But generally, from my understanding is for most of the applications is this one is already HVM, already good enough. It's just for those customer, they want to feed back their batteries back to the grid as soon as possible in 1 hour, then this will be the one you are looking at. And also this is on the backup as well. If they need a 10 kilowatt backup, HVS, that's your one. If they need 5 kilowatt backup, HVM, that's your option. But it doesn't mean the HVM cannot do 10 kilowatt. You just double the size, HVM 22.1, you have 10 kilowatt. But that require you double the size of the batteries, which is more investment, but it's your choice. And some summary features of what we just mentioned. So like lithium iron phosphate batteries, maximum safeties, doesn't matter three-phase, single phase. It's a real high voltage batteries. Each batteries they're connected in series, support off-grid, emergency backup. Some of the improvements, this is more for customers who purchased BYD stackable battery in the past few years, and we are putting a more improvements on the battery itself. For example, we're putting LED lights indicating is that system working okay. On the internet, on the communication side, we're putting more options with different inverters. You can just plug and play, and a better locking system, and basically a future-proof modular design. And also the size of the batteries goes to larger, which is you don't have to put 7, 8 of the batteries to, just putting them one by one. Now you're having less boxes and the larger batteries, and it should able to handle that one battery per one installer. It's a 40 kilograms. We talk about the HVM battery here, but we recommend 2 installers, but 1 installer, if you really, really strong, that's not the issue. And this is the summaries of, what's the difference on the old batteries and what's the, improvements on the newer batteries. And some of the improvements, for example, the system for performance in the cold temperatures, or basically, the screw fixations. These are the feedbacks we hear from the installer in the past few years. And when we design a new system, okay, we need listen to the installers, and we need to get their life, the installer life easier. And now we improve the most of the feedbacks from the old products last year, and now on the new products, they all get fixed, all right? This is one parallel connection example with the GoodWe series, 3-phase hybrid. And you can see very simple. There's no additional, like other battery manufacturer, they need their combiner box, they need their residue plus. In BYD, all you need to do is basically communication cables, the power cables, just a bus bar that's joint connected, all the positive and the negative. You have an air switch or circuit breaker. You can turn in the whole system on and off. In some countries, this is required. Some countries, this is optional. And for each of one of the batteries, we have a built-in circuit breakers, and which is you can turn in off and on the batteries. And there's no additional hardware required. This is how you're wiring. I know it's quite a simple one, but this is the wiring diagram if you need to connecting multiple batteries. And okay, just show you what, Jack already mentioned on the GoodWe which inverter that is, so I wouldn't cover too many. Just for each inverters, for each batteries, which GoodWe inverter is compatible. And I put in a TBD here, but it's already compatible here. So, and the next one will be, one example is GoodWe have their compatibility list, and BYD also have our own compatibility list. And for example, with GoodWe EH, with the HVS 12.8 is not compatible. Why is that? Because on the inverters, they have a voltage range, and just because the batteries we are having their over that inverter acceptable range. So just double check if you want to make the purchase, double check you have the correct numbers of the battery that's connecting to the inverter. And that's the end of the presentation. Do I have, how many minutes do I have in here? I would like to show you on the new batteries. Just show you on the new one. Can you guys see it? Okay. I probably need a little bit of help from my team. Just 1 second. All right, so first on this one, we have HVS, high voltage small. We have HVM, high voltage medium. And on this side, we have the LVS. Okay. All right. This is just giving you like a one example, showing, I think that's okay. That's too close. All right. Yeah, just bring down a little bit. Probably, yeah, okay. So one example is you're looking, those two are very much similar. As I mentioned, on this side, the HVS, that's the power model. That's good for kilowatt. And this one is the capacity or the energy model, the HVM, which is good for the size of the system, is slightly cheaper, but the power output is lower than this one. But generally, the difference, how you can tell what's the difference? Very simple. Could you zoom here? Yep. Could you zoom here? Yeah, I think that's fine. So basically 2 marks here, that means they are HVM, and they have like a single mark here, that means the HVS. And further down is, I would like to show you on the side of the connector. So this is what we mean is, stack. And stack design is basically there's no cable that required. All is they have a quick connector. When you do the installations, you simply just, that's basically you connect all the power cables, and basically the COM cables is all through that quick connector. Okay, I'll put back. Could you zoom here?
Yes.
Okay, yep. So basically, this is just show you one example on the, the improvements of what we mentioned. We changed on our old units. You need to get the RS-45 CAN communications. You need to wiring up differently. But now we have a different terminals. That the RJ45 terminal. That's basically you can quickly connect to each terminals, which is for different inverters, or to parallel multiple batteries. And simply just take this cover off instead of take the whole top off, and it's quite easy. And also everything is quick connected on the power connections. Yeah, it's quite simple. So I don't think there's many issues on the connections. And on the right-hand side, we have a built-in circuit breakers. And basically in some countries that require you need to access to the circuit breaker on the battery to turning off the battery immediately. And this will be the breakers, And basically if you just have one tower of the batteries, then you don't have to purchase another circuit breaker. And just to let you know that these 2 different batteries, the HVS and HVM, and they share the same top unit. So this basically very much similar. It's just depending if customer need a performance or they need energy. And do we have time to show other? Okay. This will be the one that's the 48 volts range, and it's only available, just released this month. And basically we're doing some improvements. We just want to make the installer life a little bit more easier. So for example, now we introduce a quick connectors, and if you want to take a look and basically we provide the connectors, all the installer need to do just basically reclamp the connector, which is we provided and with the cables. And then that's it. And also with the COM cables. So basically that's everything, all right? And this will be the new, the LVL 15.4, which is, you can tell the size of the batteries. So those 2 batteries, there's a 2 LVL 15.4 and a 30.8 kilowatt hour system. I believe this is one of the battery we make so compact. And so this battery is 12 kilowatt hour. This one is a 30 kilowatt hour, so 30. And you will see basically, if the customer need a large size system, this probably the one they will go with. And it's also really good for the commercial ones if you're looking at 100 or 200 kilowatt hour system. And just one more thing I would like to show you guys is on the 48 volts range, we have this one called the BMU, which is a battery management unit. So this is only required for the 48 volts range, which is the one you're looking at on the right-hand side. This is a communication unit. It's quite simple. It's basically talking to the batteries and talking to the inverters and have a power button, which is turning on the system. And this is for, like, you can think is a CAN box, which is you are required per each system. And that's, you can think is like a level 2 communications and control of the system. And all right, that's pretty much everything. And thanks you guys for listening. And thanks GoodWe to giving us the opportunity to do the presentation today. And thanks. I think it's a Q&A time. Hello?
Yes, hello. So we have some question at the Q&A function.
Hi, let me check on the. Okay, so from William, he wants a dummy unit in Sweden. Yes, okay. I'll show you one more. If you want to contacting us or demanding like a dummies, or you want to take a look at the BYD system, you can basically go to our new website, which is doing right now. Okay, so if you could go to BYD Battery-Box.com is the global website, and if you could then go to the contacting page, contact page, you will see basically, in Europe contact, the United States, Australia, and the South Africa. And we're probably gonna help you on, if you want some dummies or some further information on the BYD batteries. Also, what is the cable millimeters? Not sure what's that question from William. The copy of recordings, I believe, is a good way to the recordings we can send to the customer after.
Yes, we will provide the recorded videos via the emails to our audience.
Okay. Yep, thanks. And we have another customer asking, is that okay to connecting two BYD batteries for one ET? Yes. So I just show you at the end, which is, so basically, you can parallel two. For example, this is HVM batteries. You can do HVS parallel them, or on the low voltage range, you can parallel the LVS as well. The C value difference on 400 volts. I mean, we used to give the C values. So for example, the battery continuous, we can do 1C, which is, discharge the battery in 1 hour or charge the battery in 1 hour. And surge power is a 2C, which is the customer can potentially discharge the battery in half an hour. With the new batteries, we no longer using that term, because the battery, sometimes you can do 1C or even 2C, but with different inverters, with different size of the system, if that got limited, which is that will limiting the entire system, then you're seeing the batteries can do 1C, but the inverters only do 0.5C, which is, they need 2 hours. But yeah, like we no longer using that term, but you can think our battery is still okay or still using a 1C continuous output power. The only difference is the HVM, which is they only support 0.5C or C2, I believe what is called C2. Okay, I have another question is more in the sales. We would like to have BYD batteries for Indonesia market, but have to be bulk order. Okay, I'll get my sales colleague, Joey. He will answer that question. For Indonesia, I believe if you could email us on the BYD email here, the global sales battery box group at byd.com. And wait, can you see my screen? No. Could Leo put in the websites in the chat, bydbatterybox.com? And is it possible connecting 2 ETs for 1 BYD batteries? No, like 1 tower per each ET. You need, if you got 2 ETs, a 20 kilowatt system, just grab 2 towers of the BYD HVM, then connecting each tower to each ET. I believe that's how it works. But for some of, for the 3-phase, I believe that's a way how to doing that. But for a low voltage, will be a different, slightly different stories. But with the GoodWe, you always want 1 inverter to 1 battery. Just 1 second. So I believe that's all the questions. Yep, that should be all. And if for the questions we haven't answered, that's what we'll email or either will basically. We have one customer said 3.3 kilowatt per phase in most home applications is not enough. Yes, like in that case, if you are, but generally we're talking about a 3-phase hybrid inverters. It generally at this stage is still 10 kilowatt. So if saying, okay, customer need more power, then in that case, you probably need to think a combinations of like a 2 7 kilowatts or like a 1 large one 10 kilowatt. If they need more, putting additional either a 10 kilowatt or a 5 kilowatt. But it's more on the inverter side. Okay, yeah, that's thanks guys, and that's the end of the BYD presentation. I'll take back.
Okay, thank you so much, and I hope we all have learned a lot about the BYD battery box. So now let's move to our next part. We will see the videos about the DTA installations, and it shows the installation and configuration with BYD HVS battery step by step. Okay, now let's open the videos first.
Hello, this is Eugene from GoodWe, and today we're going to show you how to install our ET series hybrid inverter and how to connect it to a BYD high voltage battery. This is the inverter bracket for hanging the inverter. Here we have DC connectors for PV panels. And this pair of DC connectors is for batteries. Here we have the smart meter for controlling the output of the inverter and realizing the zero export function. Also, it's already connected with 3 CTs, and they're all pre-wired. This is our IC cover for realizing IP65 protection. For installing the inverter, we have all the necessary screws and screwdriver. In the small transparent bag, we have the smart meter user manual, the ET inverter user manual, and the ET quick installation and ATS report. The first thing you need to do is drill holes in the wall, and you need to make sure they are 10 millimeters wide and 80 millimeters in depth according to the dimensions of the bracket. Now, we've already done it here, but you will need to proceed with installing the wall-mounted bracket and just make sure that it's safe to proceed before you go ahead and proceed with the installation. Okay, we're going to now place the inverter on the bracket. As you can see on the sides here, we've got 2 handles which make it nice and easy to grab and nice and easy to lift too. The ET series is equipped with 2 MPPT trackers, 1 pair of battery connectors. Over here is the Wi-Fi module, and over here you can see the BMS cable and the smart meter cable. Also here you can see that we have 2 AC outputs. Okay, we're going to start with the PV input. As you can see here, we've got the PV1 plus and the minus, and we quite literally just plug it in like that. You can hear the click. PV1 plus and PV1 minus, and the same thing for the PV2. Hear the click for the PV2 plus and the minus. As we just mentioned, we've got 2 AC outputs, one for the on-grid and one for the backup, and we've got 5 cables for each one. We've got the L1, L2, L3. The black one is the neutral cable, the green and yellow is the PE grounding cable. You need to make sure we start from the backup and we just connect them like so, and just make sure they're safely connected. Okay, now that we've finished connecting the AC side, we're just going to connect the waterproof cover for the AC side. Okay, and once the AC connection is done, don't forget the grounding cable with the side panel, very important. You just connect it here like that and tighten it. Okay, we're now going to show you the smart meter connection, and in order to help you with the smart meter connection, we're just going to show you a project that we have here in our factory. So this is the smart meter cable, and the smart meter cable should be connected right here to the smart meter connector. There are 4 cables, and the 3 red ones should connect to the L1, L2 and L3 phase of the MCCB box. And the black neutral cable should be connected to the neutral line of the AC connection. There are 3 CTs, and each CT should be connected to the same phase as the smart meter. The position of the CTs should be between the house loads and the grid, and also the direction should be from K to L, so from the house loads to the grid. Okay, we're now going to connect the inverter to the battery. There are 3 steps here. First, we need to connect the BMS cable to the battery. The BMS cable is pre-made, and we only need to complete the other side. The BMS cable comes pre-wired. You just need to cut the other side that connects to the battery. And in this case, we need to select the first 2 wires over here, the blue one and another one that is blue and white. And you should have the blue wire in port 1 and the blue and white one in port 2, like so. And once you've got the wires in, you just place the BMS connector in the BMS receiver on the battery end, like so. Okay, the BMS cable connection is complete, and now we're going to connect the power cables from the inverter to the battery. For the power cable, as usual, red is positive, black is negative, and you quite literally just plug it in and wait for the click like that. That plus and that minus. Okay, so we've got the power cables connected to the inverter, and then we connect the other side to the battery power connector. And the trick for the battery connector is just simply lift this switch over here, and you place the positive, and the same for the negative, like so. Make sure it's safely connected. And the last step is to perform the dip switch configuration. Please make sure the 3 dip switches are all on the left. Okay, once you've got the cover back on, you can now power the inverter on with the battery by just using this switch over here. And as you can see, the inverter is now being powered by the battery. The battery connection is done, and we can now proceed to the battery configuration. First, we need to turn the Wi-Fi off and leave your mobile data on, and then we can launch the BConnect app. Choose the correct language and click Confirm. Click Confirm again when you've read the terms of the privacy policy. Click Yes and start configuration. Click Download firmware. Once you've successfully downloaded the firmware, we can connect to BYD Wi-Fi and proceed. Go to the Wi-Fi settings and select BYD Battery-Wi-Fi and enter the password BYD-B-box. Pay attention to capital letters. Return to the home screen and click on BConnect again. Click Update Firmware if there's a new update, or you can click Confirm to move forward if your device already has the latest firmware. Click Confirm and we can proceed to the detailed settings. Step 1. Confirm the time and make sure the battery is synchronized with the current time. Step 2. Click to select the inverter model as GoodWe and click Confirm to proceed. Step 3. Select the battery model name and select the number of battery modules per tower. Click Confirm and proceed. Step 4. Click Grid to choose On Grid. Click Phase to choose 3-phase. Then click Confirm and check the box. Then submit the configuration for the battery. Click Complete. Now we finished the configuration on the HFZ battery. Now we need to disconnect the BYD Wi-Fi and continue the inverter configuration on the PV Master app. Launch the PV Master app on your phone and click Connect Device. Select Inverter with Wi-Fi and go to Wi-Fi settings. Find the solar Wi-Fi SSID name. The Wi-Fi password is 123456778 and wait until connection is complete. Go back to the PV Master and swipe down to refresh. You will see the device listed. Click the device name and enter the system overview. You can click the parameters and scroll down to view the last 2 digits of the firmware. Please make sure the ARM version of the ET is over 11 when you try to use the BYD high voltage battery. Now click Settings and click the basic settings. Enter the password GoodWe 2010 and click Login. The first setting is to choose the safety of your area and then click Next. The second setting is to choose the correct work mode of the inverter based on the specific requirements and conditions of the site. Click Next when you're ready. The third setting is to choose the correct battery model name. The system will detect the battery model and capacity if you did the battery configuration correctly. Now just click Set to confirm configuration and click Next. The last step is the meter test. You can enable the meter test to check the meter and CT connection if the connection has been done properly. Click Exit and confirm the change by clicking on Yes. Configuration will be saved once the equipment has restarted. Once the equipment has restarted, we can go back to the system overview window to confirm if the BMS status is normal or has failed. Please contact a GoodWe technical support engineer if the BMS status still fails after several attempts. Besides the basic settings, customers can choose to enable some other functions based on the real conditions of the plant. Okay, the inverter and battery configuration is done. Thank you for watching this video and feel free to contact our service team if you need any support.
Thank you so much for today's webinar. And for more information, you can follow us Facebook and YouTube channel. And we will upload the latest information and videos frequently. And also you can go to our official website to see the latest information of our webinar. And you can also download our technical document at the website. It is a really useful website. And let me type our website at the chat box. Yeah. Here's the address of our website. So, thank you for joining today's webinar and hope you have learned a lot of our energy storage system. And also very big thanks to Jack and Jay for providing us such a great presentation. We hope to see you guys again. Bye.